Module 3 VLANs. Okay. Module title regarding protocol and models. This module, okay, will explain how network protocol enable devices to access local and remote network resources. So in this module, we have a couple of sub-module or subtitle, which are overview of VLANs, VLAN in a multi-switch environment, VLAN configuration, VLAN trunks, and finally, dynamic trunking protocol. 3.1 overview of VLAN. VLAN definition. VLAN are logical connection with other similar devices. Placing devices into various VLAN have the following characteristic. First, provide segmentation of the various groups on the same switches. Next, provide organization that is more manageable. And broadcast, multicast, and unicast are isolated in the individual VLAN. With VLAN, each VLAN will have its own unique range of IP addressing, and with VLAN, it can smaller broadcast domain. So this is diagram of the VLAN. How we group the VLAN logically, yeah, according to their categories, department, and whatsoever. Okay, so in this case, we group logically based on the department. Here, they group based on the IT, HR, and also next, this one VLAN for the sales, right? Okay, benefit of VLAN design. So with VLAN, actually, we can make it smaller broadcast domain. Okay, by dividing the LAN, so it will reduce the number of broadcast domain. And also, it can improve the security. Only user in the same VLAN can communicate together. And next, for improve IT efficiency, VLAN can group devices with smaller requirement. For example, faculty versus student. And also can reduce costs where one switch can support multiple group of VLAN. So with VLAN also can better performance with small broadcast domain, reduce traffic, improving bandwidth. Finally, it can make it simpler management, where similar groups will need similar application and other network resources. So this is the VLAN, how we design the VLAN. Okay. Virtually, we are in the same group, and physically they are separated. Okay. Type of VLAN. Default VLAN. VLAN 1 is the following the default VLAN. So also the default native VLAN. So it can be the default management VLAN. So cannot be deleted or renamed. So the default is a VLAN, like this example. So note, while we cannot delete VLAN 1, Cisco will recommend that we assign these default features to other VLAN. Data VLAN. So dedicated to user-generated traffic, email or web traffic. VLAN 1 is the default data VLAN because all interfaces are assigned to this VLAN. Native VLAN. This is used for trunk links only. All frames are tagged on an 802.1q trunk link, except for those on the native line. So we got another VLAN, which is management VLAN. So this is used for SSH or telnet VTY traffic and should not be carried with end user traffic. Typically VLAN, that is the SVI for the layer 2 switch. Okay, SVI stands for switch virtual interface. Voice VLAN. A separate VLAN is required because voice traffic required what? Actual bandwidth, high quality of service priority, ability to avoid congestion, delay less than 150 milliseconds from source to destination, and the entire network must be designed to support voice. Okay. So packet tracer, who hears the broadcast? In this packet tracer activity, you will do the following. Observe broadcast traffic in VLAN implementation and complete the review questions. So this packet tracer, you can check in your NetHackett, try to do this activity, and in order to understand for the concept of virtual LAN, for those who are very first time on this subject, okay, or the issue of the virtual LAN, yeah. (3.2) VLANs in a multi-switch environment. Defining VLAN trunks. A trunk is a point-to-point link between two network devices. Cisco trunk function will allow more than one VLAN. Extend the VLAN across the entire network. And by default, it supports all VLAN. So support 802.1q trunking. Okay, this is the trunking. Okay, the one that they highlighted here. This one. Yeah, this is the trunking. Okay, so we need to have this kind of trunking in order to connect between these two topology or separated. Yeah, so this is a function of the trunks, okay, or VLAN trunks. Network without VLAN. Without VLAN, all devices connected to the switch will receive all unicast multicast, and also broadcast. So that's happen if we don't have VLANs. Okay, so this switch, try to imagine that switch is a layer 2 device. Yeah. So if we do all this, unicast, multicast, and also broadcast, so we cannot control that. Okay, especially on broadcast. Okay, through VLAN, we can manage that. Okay. Network with VLANs. So with VLANs, unicast, multicast, and also broadcast traffic is confined to a VLAN without a layer 3 device to connect the VLAN. Devices in different VLAN cannot communicate. Okay, so here it shows that VLAN support configured to support VLAN 10 and 20. Okay, so this is a trunking. This is a trunking. Okay, they're going to support between VLAN 10 and also 20. All right. So this is a frame. We talk about the frame. The VLAN indication will attack. So in IEEE, 802.1q header is a 4 bytes. When the tag is created, the FCS must be recalculated. When sent to end devices, this tag must be removed and the FCS recalculated back to its original number. Okay, this is the type, the content or the content field that if they're going to develop this VLAN, the new what we call this the algorithm, okay, protocol especially. So they will do change on the real, okay, real what we call this the real one without the VLAN, okay, protocol. So that's why they need to, when they started to introduce this, so they have this field, extra field, need to do some modification in the protocol. So they got type, user priority, SFI, and also VLAN ID. Okay, in order to implement this VLAN, so in protocol, they need to do some changes. Okay, so these are the fields that they're going to support the VLAN. Yeah, so here they call VLAN identification with a tag. So every packet they will put a tag in. That's why they can manage all these packets. Okay, unicast, broadcast. Yeah, unicast, broadcast, all those. Yeah. Okay, so we need to know as well, but we're not going to develop a new protocol. So we are using VLAN protocol created by these Cisco devices. Okay, so all the product from Cisco are using VLAN. So this is the format. Okay, they created, so they must have some fundamental issue, especially on this protocol. Yeah. So native VLAN and 802.1q tagging. Okay. 802.1q basics trunk basic, tagging is typically done on all VLAN. The use of a native VLAN was designed for legacy use like the hub in the example. Unless change, VLAN is the native VLAN. Both ends of a trunk link must be configured with the same VLAN. Yeah, same native VLAN. So each trunk is configured separately. So it is possible to have a different native VLAN on separate trunks. Okay. Okay. Back to this. Okay, this is, you can see that a separated VLAN one. Physically, they are separated, but with this VLAN, they can, connects. Logically, they are in the same group, VLAN one. So that's why we need to have this, yeah, trunking, okay, in order to connect, yeah, to connect all the, I mean, the group of the VLAN. All right, okay. Voice VLAN tagging. The VoIP phone is a 3-port switch where the switch will use CDP to inform the phone of voice VLAN. The phone will tag its own traffic like voice and can set cost of service COS, and cost is the quality of service for layer 2. Right? The phone must be, the phone may or may not tag from the PC. So traffics here, we have voice VLAN. So tagging function, it will tag with an appropriate layer 2 class of service COS priority value. And SS VLAN can also be tagged with a layer 2 COS or class of service priority value. And for this SS VLAN is not tagged, so no layer 2 cost of service priority value. Okay, here are the examples. Okay, voice VLAN verification example. Okay, so the show interface, FA, yeah, port number FA0/18 switch port command can show us both data and also voice VLAN assigned to the interface. Okay. Okay, so when we use this command, so this is the detail of that interface. Yeah. All right. So this is also another packet tracer. You can try to do that. Okay. So in order to understand the concept of VLAN. Yeah. So 3.3 VLAN configuration. Okay, VLAN range on catalyst switches. Catalyst switches, okay, 2960 and 3950 support over 4,000 VLANs. All right. So mean 4,000 number of VLANs. A normal range VLAN is between VLAN 1 till, till 1,005. So it can be extended range VLAN from 1,006 to 4,095. So used in small to medium-sized businesses and used by service provider And for 1002 and 1005 are reserved for legacy VLAN. So all these are in running config. For 1 and 1002 and 1005 are auto-created and cannot be deleted. Okay, and also it stored in the VLAN.dat file in Flash, and VTP, yeah, can synchronize between switches. Okay, so extended range for VLAN used by service providers and are in a running config and support fewer VLAN features and also required VTP configuration. All right. So VTP stand for Virtual Trunking Protocol. VLAN creation command. VLAN details are stored in the VLAN.dat file. You create VLANs in the global configuration mode. Okay, task. Enter global configuration mode. Okay, first you need to enter using this. Okay, when in the command from switch hashtag here, you type configure terminal. So it will change to another mode. Okay, so it will change to global configuration modes. Yeah. Next, create VLAN with a valid ID. So when it's changed next here, so they put config here. So you start create VLAN. VLAN, and this is VLAN dash ID. So you can put any numbers and specify a unique number to identify the VLAN. So once you put ID, VLAN number, as we know that it can assign till 4,000. So normally we start with 1, 2, 3, and so on. Sorry, 1 is for reserve, so 2 and so on. Yeah, and then the name of the VLAN. And after that, return to the privilege exec mode by put n, n, and enter. So it back to the enter global configuration mode. Right? Okay. VLAN creation example. If the student PC is going to be in the VLAN 20, we create a VLAN first and then name it. Yeah. If you do not name it, the Cisco iOS will give the default name of VLAN and the 4-digit number of the VLAN. For example, like this example. Yeah. So this is how you assign. Okay, once the VLAN is created, you can then assign it to the correct interface. Yeah, interface. So first, enter the global config mode with this command, and then choose the interface. So enter the interface configuration with this command, and then set the port to access mode. So switch mode access. Okay. So to that port, and then assign the port to a VLAN. This command switch access VLAN. So which interface or which port. Okay, here they use the word port. Some we use interface. And then return exec. So I mean you put n, so it will close this in order to configure that. Yeah. So we can assign the VLAN to the port interface. Okay, once the device is assigned to the VLAN, then the end device will need the IP address information for that VLAN. Here, student PC receive 172.17.20.22. Okay, so for example, in this, we got switch here and go to the global config mode, type configure terminal, and goes to the which interface. So FA0/18, and then write the mode access. and which VLAN, and then close. Okay, this is how we configure this. Okay, all right. Data and voice VLAN. An access port may only be assigned to one data VLAN. However, it may also be assigned to one voice VLAN for when a phone and and device are off of the same switch port. Okay, all right. Here. Okay, switch port must support VLAN traffic for voice traffic and also data traffic. Yeah. Data and voice VLAN example. We will create, okay, we will want to create and name both voice and also data VLAN. In addition to assigning the data VLAN, we will also assign the voice VLAN and turn on quality of service for voice traffic to the interface. And for the newer catalyst switch will automatically create the VLAN if it does not already exist when it is assigned to an interface. Note, QoS is beyond the topic or the scope of this course. Here we do show the use of MLS quality QoS trust, okay, all these COS, and then pipe device Cisco phone, pipe DSC, pipe IP president, and command. Okay, so we just use this later, yeah. Okay, because quality of service we will learn later, not in this course, yeah. Okay, here are the command how we set that for that particular this. Okay, interface. Okay, next. Verify VLAN. So once you create, you need to verify. Okay, use the show VLAN command. The complete syntax is show VLAN. Either you can use brief or specific to either VLAN or the name of the VLAN. And also you put summary. Okay, it will show the information about the VLAN. Okay, like this command. Okay, if you put the brief, it will show the display name status and its port for port 1 VLAN per line. Okay, and if we put the ID for VLAN, so it will display information about the identified VLAN ID number. And next, we put VLAN name, so it display all the information about the correspond VLAN. Okay, and display some VLAN summary if you put summary. Okay, all right. They are the example of the verification or information comes when you type the show VLAN summary, and also this one show VLAN interface VLAN 20. Okay, so you can check whether this one is very important. This one shows the VLAN 20 is up. Okay, like that. And change VLAN port membership. There are a number of ways to change VLAN membership. Yeah, to re-enter switch for access VLAN, switch ID. Okay, and then command and use the no switch for access VLAN to place interface back in the VLAN 1. Okay, we use this to verify, show VLAN brief and show VLAN, show interface FA0/18 switch port command to verify the correct VLAN association after we change that. Yeah. All right. Can delete VLANs. Delete VLAN with no with the no VLAN and also VLAN command. So we use no at the beginning. So in the VLAN, and the number of VLANs. Okay, we use that. And then please be cautioned because before deleting a VLAN, reassign all memory port to a different VLANs, to a different VLANs. So delete all VLAN will delete this, yeah, VLAN.dat, and also this to delete all the VLAN we use this command as well, yeah. So reload the switch when deleting all VLANs. So you have to turn it off, and also on. So or this here they said reload the switch when deleting all VLANs. So after that it will reset. Sorry, back to the what based on the you have been configured. So not to restore to factory default, unplug all data cable, erase the startup configuration, and delete the VLAN.dat file, then reload the device. Okay, here are another packet tracer regarding for configuration. You can try it, okay, to understand how to configure, to create, then configure, and later on after that verify it. Yeah, all right. So VLAN trunks. So trunk configuration command. Configure and verify VLANs. Trunk are layer 2 and carry traffic for all VLAN. So the first task goes to this enter the global configuration mode, and then after that you have to enter the interface configuration mode. So what's your ID, which interface, and then set port to permanent trunking mode by this command. Okay, and then next you have to set the native VLAN to something other than VLAN 1. Okay, so we do configure on this using this command. So which, okay, and then specify the list of VLAN to be allowed on the trunking list by this switch port trunk allowed, and then which VLAN, okay, and then after that, and to return to the privilege exec mode. Okay, once you've done that, this configuration. Okay. So trunk configuration example, the subnets associated with the each VLAN, if you can see here, we design VLAN 10, and then this is the IP for VLAN 10. So this is the name of the VLAN. Okay, the same for other, you have to design it first, yeah? So like this example, okay? And then you have to determine as well. So this one, interface FO/1 port on S1 is configured as a trunk port. Okay, so I think in the diagram it shows which one is a trunk. Okay, so note this assume 2960 switch, okay, the model using 802.1q tagging. Layer 3 switch require the encapsulation to be configured before the trunk mode. Okay, here are the command to use, yeah, to configure that. Okay, so verify trunk configuration. Set the trunk mode and native VLAN. Okay, that is show interface. Okay, FA0/1 switch port command is set to trunk is set to the trunk administrative. Okay, and then is set as a trunk operational or functioning, and encapsulation is .1q, and native VLAN set to VLAN 99, and all VLAN created on the system will pass traffic on this trunk. Okay. Okay. Reset the trunk to default state. Reset the default trunk setting with the no command. Yeah, with no. Yeah, normally this product or Cisco product we are using no at the beginning. Yeah. So all LANs okay allowed to fast traffic. Okay, we reset to the normal. So native VLAN will set to VLAN 1. So verify the default setting with a command show interface have a switch port and a switch port command. So to verify mean to check again. Yeah. So after we do the resetting, and then we use this command to double confirm the access mode VLAN back to the default, which is 1, and also the trunking VLAN also enable to all. Yeah. And reset the trunk. So reset the trunk to an access mode with the switch mode access command. So it's set to an access interface administrative, and is set as a access interface operational functioning. Yeah. Okay. So this, and then back to here to check again, and switch for enable and necessary mode change to the static access. Yeah. And this is another packet trace activity you can try in from the our NetAcad. So through this packet tracer, you will verify and also the configure a trunking. All right. Okay. Please do this. Yeah. So later I will create my own activity to answer all this module. Yeah. All right. Okay, this is also another activity which include VLAN and trunking. So this is the physical mode activity. So where they create using the packet using a packet tracer with physical mode. Yeah. So the activity regarding configure VLAN and also trunking. So in this packet tracer physical mode activity, in this that you will create the following objective. So build the network configuration, understand that, okay, design, and also next you have to create. So and then assign a switch port and maintain VLAN for assignment with the VLAN database, configure trunking. Okay, where configure this here, they said 802.1q trunk between the switches, and this one we do that. Okay, in the lab actually. Okay, so this we need to know how to delete LAN and configure back and so on, reset the setting. All right. Okay. So we stop in this part and we continue later. All right. Okay.